Hello, this is a presentation produced by 2020 Crystal Clear Vision on the topic of cataracts. We are located at 12639 Blanco Road, San Antonio, Texas, right off the corner off of Blanco and Wurzbach Parkway. This is presented by Dr. Bustamante, who is a subject matter expert on ocular anatomy and ophthalmic optics. And that is some of our contact information. Our telephone number is 210-419-4300. Let's get started. So today we're going to be talking about cataracts, how it's formed, exactly where it's located. So here you will see through the pupil, which is that dark area in the center of the lens there, you will see the cortex, the anterior lens capsule. So this is the crystal lens. It kind of looks like the universe, and I'll show you a picture of that at the very end. We have an optic section going through the front part of the eye, echoing there with the corneal beam on the front surface, which is the cornea, going all the way through from the anterior lens capsule, back through the cortex, through the nucleus, all the way back to the posterior lens capsule, and you can see the concave shape, lens in the very background. So what are the causes of cataract? Well, the number one cause is age. So it affects all of us with aging. People, of course, know that the UV light from the sun is a big cause of that. Our lens is a light green color when we're little. Just like a banana, it goes from a greenish to a yellow to a darkish brownish. There are other causes of cataract besides the sun and the UV, but congenital cataracts are common, which causes amblyopia because it deprives the eye from the information, the sensory information coming in from the light. It also happens in very young children. That's why they need examinations too. It can also be caused by blunt trauma to the eye, surgical trauma whenever there's a retinal detachment surgery, for example, or long-term topical steroid use, and there's other causes as well, but we'll talk about that here shortly. So here is the crystalline lens and its relationship to other internal structures within the eye. The crystal lens is there hugged by that black concave line outlining the posterior surface of the lens. This is the cornea, which is the front part of the eye. It's kind of like the windshield of the eye. The anterior chamber is a clear space where fluid, aqueous humor, circulates in convection currents. Here we have the iris. It is dilated. The iris is Greek for rainbow, and of course there's different colors to everyone's iris, and that gives them their characteristic color to each of the eye. Here in the middle, here in between the anterior chamber, between the cornea and the iris, I should say, is the angle, also known as the trabecular meshwork, where the fluid drains out of the eye, and also is an important consideration for diseases like glaucoma. What do we got here? We got the sclera, or the white of the eye. We have the ciliary body, which produces the aqueous humor. It also regulates the ciliary zonules that attach to the crystal lens. Here we got the posterior chamber where the fluid is made and circulates through the pupil to the anterior chamber. Here we have the zonules of Sin, as they call them, which are attached to the crystal lens. Here we have the pupil, which is the dark black center where the light is funneled into, going through the crystal lens and focusing on the retina on the back of the eye. And here is the crystal lens, and that's where it's situated in relationship to other internal structures. The patellar fossa is a little indentation on the vitreous, which is posterior, just behind the crystal lens, and that is where the crystal lens sits in the very back. This crystal lens is about 9 to 10 millimeters in diameter in the adult. It's a little bit smaller in a child, but it does grow kind of like a tree trunk every single year, and is one of the reasons why we lose our ability to focus up close with time. So cataract comes from the word cataratas, which means waterfall, and you can notice this cortical cataract on your left-hand side, which kind of looks like a waterfall. So we're going to give some images here very quickly. So that is a cataract. That's the eye. Again, we're looking at a retroillumination where red light is bouncing from the back of the retina to the front. We can see a little opacity there in the shape of an upside-down Y, kind of coterminous, or coincident, I should say, with the sutures, which look like Ys. Here's a nuclear sclerotic cataract, which nuclear means it comes from the nucleus, the very center. Sclerotic because it does opacify with time. It has this kind of yellowish tinge to it. Things can't get in through. It has that yellow appearance, like we mentioned earlier, because it's trying to block the higher energy blue light, the UV light that's coming in from the environment. It's another optic section through a cataract there. Some of these cataracts do take on an appearance that reminds us of certain things. This particular cataract on your left kind of looks like a Christmas tree, so someone called it a Christmas cataract, which it certainly looks like that. And there's a picture on your right to kind of show you the image to kind of get the idea that it's showing there. Here is a cortical cataract that I've collected. It kind of looked to me like a sand dollar, and so this one you could call it a sand dollar or cortical cataract. Some of these cataracts are more prominent and will disturb your vision more at night. Here's a posterior subcapsular cataract right in the center there, and to me it looked like it looks like a jellyfish, so I called it a jellyfish cataract there. Here's a posterior subcapsular cataract. To me, that looked like an opacity there in the center. You can see how this one would affect your central vision, whereas some of the cortical cataracts could interfere with your peripheral vision. So this looks kind of like a tree stump there, and it certainly looks like that. This was a sugar cataract from diabetes, and you can see how the sugar cataract, well, it looks like a sugar cookie. So too much sugar can actually deposit in the crystal lens, transforming itself into a sugar alcohol called sorbitol, causing an opacification of the clear lens fibers, creating an opacity and causing this sugar cataract, blocking any kind of light from properly focusing an image on the retina on the back of the eye. So how do we get rid of them? Well, we go in there and just like an egg, we can go in there like a hard-boiled egg and basically kind of suck out that lenticular kind of debris and eliminate it and put in a clear lens, which is smaller than a dime. You can see it there on your upper right, these little implants with little haptics situated in there. So you suck out the cataract and you make a small incision on the sclera corneal junction and just put the lens implant inside, and voila, it's simply like replacing a dirty window in the eye and replacing it with a clear window, and that's what it looks like there. And that's the end of our cataract lecture. That's the crystal lens on its side. It kind of looked like the universe to me, and so it's quite interesting how we see the universe through this crystal lens. Again, my name is Dr. Bustamante at 20/20 Crystal Clear Vision. Thank you and have a nice day. We look forward to seeing you, taking care of your family's needs, and any other ocular questions you might have, please see us and call us. Thank you.